Take a deep breath in and a slow, gentle breath out. Allow the tension from your day to leave your body. Feel your shoulders drop and the muscles in your face relax. Tonight, we embark on an extraordinary journey. Imagine yourself drifting through billions of years of our planet's serene history. We aren't just resting. We are tracing the path that led to this very moment, to your tranquility right here. Right now, this is the story of evolution, the slow, unstoppable force that transformed a primal ocean into a complex, multifaceted world. From the very first invisible cells that sparked in the water, through green forests, the age of magnificent dinosaurs, right up to the emergence of thought and consciousness in the human being. Close your eyes. Let this rhythm, this narration, carry you forward. Every stage of this monumental journey will guide you deeper into your rest. Let the story of evolution lull you to sleep. Now, as you settle deeper into the cushions beneath you, let your body become heavy and perfectly still. Allow your mind to begin its long, slow journey back in time, not just millennia, but vast, uncountable eons. We are going back far beyond human memory, beyond mountains and oceans to the very cradle of existence itself. Our journey begins 4.5 billion years ago, in the era known as the Hadean Aeon, a name that whispers of fire and primal creation. Picture the Earth then. It was a world utterly foreign to our modern senses, a place of profound geological turmoil. There were no gentle blue skies. Instead, a thick, dark, toxic atmosphere enveloped the globe, dominated by steam, carbon dioxide, methane, and sulfurous gases endlessly spewed from a surface that had not yet fully solidified. The landscape below was a chaotic tapestry of molten rock and cooling crust, constantly being reshaped by titanic forces. Gigantic asteroid impacts were routine, striking the planet with devastating force, melting vast swaths of the surface and instantly vaporizing water. This was an infancy defined by violence, yet beneath this inferno, the conditions for life were slowly, inevitably, being prepared. Feel the deep, resonant rhythm of that ancient world. It is not a frantic sound, but slow, powerful, and persistent, the low subterranean rumble of volcanic activity, the hiss of superheated steam, and the endless, gentle rain that began to fall as the crust cooled. This rain was relentless, continuing for millions of years, gathering in the immense depressions of the landscape and forming the first oceans. These waters were not clear and blue, but deep, dark, and warm, a dense, mineral-rich cocktail. They contained the raw, inert ingredients necessary for the grand experiment of life: carbon, hydrogen, oxygen, nitrogen, and phosphorus. These fundamental elements, scattered across the cosmos, found their perfect laboratory in the planet's sheltered, bubbling oceans. It is in these depths, protected from the surface storms and solar radiation, that the true miracle of our story unfolds, the process known as abiogenesis. This is the moment when chemistry transcended itself and turned into biology, where lifeless matter first began to stir with an inexplicable, self-sustaining purpose. Visualize the water molecules moving with infinite patience, guided by energy emanating from two critical sources. First, the deep-sea hydrothermal vents, volcanic fissures on the ocean floor that released scalding, mineral-laden fluids. This provided the heat and chemical gradient needed to drive reactions. Second, the constant lightning strikes and the remnants of the sun's ultraviolet energy penetrating the shallow waters, acting as electrical sparks in the massive chemical reactor. Under these conditions, simple inert molecules gently mingled, forming increasingly complex chains structures known as amino acids. Think of these as the fundamental, color-coded beads that will eventually be strung together to form the long, complicated proteins of life. They organize themselves into the intricate spirals of RNA and DNA, molecules with the astonishing ability to store information and, crucially, to copy themselves. Let the image of the primeval soup soothe you. It is vast, silent, and infinitely patient, incubating the mystery of existence. These self-replicating molecules eventually found protection by forming simple barriers, tiny, self-contained bubbles surrounded by a lipid membrane. These were the protocells, the ancestors of everything that walks, flies, or swims today. They were not yet alive in the modern sense, but they represented the first quiet whispers of life. Having learned the essential trick of survival, self-assembly and replication, around 4 billion years ago, the first true cell emerged. It was a prokaryote, a beautifully simple, single-celled organism, lacking a true nucleus. Its DNA simply floated within the cell. Its entire existence was focused on two things: consuming energy from its environment and replicating itself successfully. These microscopic pioneers were the sole residents of Earth for the next 2 billion years. 2 billion years. Feel the sheer immensity of that time. It was an age of quiet, steady microbial life, a deep, enduring stillness that set the stage for everything else. This period, longer than the entire subsequent history of complex life, was defined by continuous, gentle, invisible activity. The oceans filled with this life, a vast, silent, microbial biosphere. Many of these prokaryotes, seeking better survival strategies, evolved a monumental new ability: photosynthesis. Imagine the first time a simple organism used the energy of sunlight to convert water and carbon dioxide into sugars for fuel, releasing a new reactive gas as a byproduct. That gas was oxygen. This event, which unfolded over millions of years, is dramatically named the Great Oxidation Event. For the existing, anaerobic life, the life that had thrived without oxygen, this gas was a deadly poison, a catastrophic pollutant. It triggered one of the largest mass extinction events in history, wiping out countless anaerobic species. Yet, as oxygen slowly accumulated in the oceans and then gradually permeated the atmosphere, it fundamentally reshaped the world, creating the breathable air we rely on today. This quiet microbial change was the single most transformative event in planetary history, paving the way for organisms that could utilize oxygen's potent energy to become larger, more complex, and more dynamic. Feel the slow, steady persistence of these early cells. They endured volcanoes, they survived mass extinctions, and they patiently created the conditions for the entire vibrant world to follow. 2 billion years of silent, continuous evolution is a profound thought. It reminds us that true, great change does not happen in a flash of noise, but through deep, unhurried time. Let the vastness of that time calm your thoughts. There is no rush here, only the powerful, predictable rhythm of creation. As these simple prokaryotes adapted to the new oxygen-rich world, they opened the door to the next great leap in complexity, setting the stage for the dawn of the multicellular era. Rest now, with the rhythm of the ancient ocean in your ears, carried by the quiet resilience and endurance of the first living things. We continue our journey through time, allowing the next chapter to gently guide you deeper into sleep. As you rest, carried by the quiet resilience of the first living things, we move slowly forward in time. We leave behind the turbulent, chaotic world of the Hadean and enter a new, stabilizing age where the air is still thin, but the oceans are brimming with a profound, invisible potential. For over 2 billion years, a span almost impossible to comprehend, the simple, single-celled prokaryotes ruled the earth. They were the masters of survival, efficient, uncomplicated, and perfectly suited to the harsh environment. Yet within this vast, quiet microbial kingdom, the stage was being set for the next great leap in complexity, a biological act of union that would forever change the scale of life. Approximately 2.1 billion years ago, the first great organizational breakthrough occurred, the emergence of the Eukaryotes. Imagine a pivotal, chance moment in the ancient sea. One simple cell, larger than its neighbors, performs a strange act of engulfing a smaller cell. But instead of digesting it, the larger cell incorporates the smaller one, forming a symbiotic relationship of partnership. The smaller cell, perhaps an ancient bacteria, becomes the powerhouse, the mitochondrion, providing far more efficient energy than the host cell could ever produce alone. This single event, this ancient, internal partnership was a true revolution. The new, larger cell was an entirely different organism, now housing a true nucleus to contain its genetic material and specialized internal structures, the organelles to manage complex tasks. This eukaryotic cell was exponentially more powerful and versatile than its prokaryotic ancestor. Let the image of this ancient cooperation fill your mind. It is a story of integration, a profound lesson in how unity creates power. The eukaryotes flourished, becoming the dominant form of single-celled life, capable of sophisticated movements and complex feeding strategies. But the eukaryotes were still alone in their singularity. The next major transition required not internal partnership, but external cooperation, a biological friendship that would fundamentally change the size, scale, and shape of life on Earth. Drift now towards the Neoproterozoic era, approximately 800 million years ago. This era was characterized by profound geological stress, including periods when the entire planet may have been encased in ice, the dramatic and punishing Snowball Earth events. The oceans froze over, and life was forced to cling to tiny refugia near volcanic vents. These crises acted as powerful, brutal pressures, forcing life to adapt and innovate in extreme, yet necessary ways. It is out of this enormous adversity that the first multicellular organisms finally began to thrive. Picture a simple colony of eukaryotic cells. At first, the cells were identical, only gathering together for simple mutual protection against the harsh external environment. But slowly, over countless generations, a profound innovation took hold. Cell specialization, Some cells began to focus solely on digestion, becoming the internal structure. Others dedicated themselves to sensing the environment, becoming rudimentary exterior surfaces. Still, others focused exclusively on movement or on reproduction. This division of labor was the key to building larger, more durable, and more resilient bodies. No single cell had to do everything. They worked as an interdependent team, a collective dot. Feel the slow, smooth transition from the solitary existence of the single cell to the deep, complex power of cooperation. This is the moment life began to discover the profound strength found in community and differentiation. The oldest known animal embryos and fossil traces suggest that by about 600 million years ago, the first true multi-celled creatures were gliding and adhering to the ancient seabeds. This marked the beginning of the Ediacaran Biota, a mysterious, gentle collection of soft-bodied creatures unlike almost anything we see today. Visualize these Ediacaran organisms: large, simple discs, quilt-like geometric shapes, or beautifully patterned frond-like organisms gently adhering to the seabed. They were still deeply simple. They did not possess the complex features we associate with animals: no mouths, no guts, no true eyes, and no limbs for active locomotion. They simply existed, swaying gently with the currents, absorbing nutrients directly from the water. They were strange, silent, and deeply resilient, the quiet, ghostly pioneers of the animal kingdom. This Ediacaran era was defined by quietude, stillness, and slow, passive growth. The pace of evolution was deliberate and unhurried, as life learned the fundamental rules of being large, structured, and organized. This period of soft-bodied stillness lasted for many millions of years, leading us right up to the very threshold of the most dramatic and rapid diversification of life in Earth's history, the Cambrian explosion. Feel the calm of the Ediacaran seafloor. The water is cool, dark, and perfectly silent. Life here is simple, restful, and deeply interdependent. This time, spanning tens of millions of years, was the final preparation. Below the surface, the building blocks were being rapidly assembled. The genetic codes were becoming more complex, allowing for the formation of calcium carbonate shells, the first rudimentary exoskeletons, and the very first complex nervous systems. The evolutionary gears were turning, silently gathering speed, leading toward a spectacular burst of creativity. Rest here, at the edge of this vast, silent ocean. The stage is set for complexity, for the first bones, the first true eyes, the first jaws, and the sudden, dramatic discovery of active, purposeful movement. But for now, there is only the quiet, collective existence of the first multi-celled beings, swaying in the darkness. Let the image of these tranquil, primordial oceans carry you deeper into your rest. Feel your mind settle, following the slow, steady rhythm of this vast, unhurried evolution. You are safe in the knowledge that even the largest, most complex life began with this quiet act of deep collaboration. Sleep now, as the next great chapter of life awaits your gentle arrival in the depths of your dreams. As you drift now, we leave the silent, soft-bodied world of the Ediacaran seas and approach a monumental turning point in life's history, a period of sudden, explosive creativity known as the Cambrian explosion. We are now approximately 541 million years ago. Imagine the serene silence of the deep ocean floor being shattered, not by violence, but by innovation. Within a span of just a few tens of millions of years, a blink of an eye in geological terms, life suddenly discovered the power of hard parts. Shells, armor, spines, and primitive skeletons began to emerge, providing protection and structure. This sudden appearance of mineralized tissue allowed for a dizzying array of body plans and complexity that had never been seen before. Picture the sea now teeming with creatures that look strangely familiar, yet utterly alien. Trilobites, segmented arthropods, roll along the seabed, protected by their intricate shells. The first simple fish, jawless and armored, glide through the water. Creatures with multiple eyes, gripping appendages, and sharp defenses fill every niche. This was an evolutionary arms race, but viewed through the lens of sleep, it is a magnificent, slow-motion ballet of biological diversity. Rest now, and observe the beautiful structure of these early animals. They developed symmetry, allowing for active movement and direction. They discovered the anterior and posterior, a head and a tail. And perhaps most critically, they developed eyes. The emergence of true vision, the ability to process light and perceive the environment, fundamentally changed the relationship between predator and prey, driving even faster innovation. Feel the gentle currents carrying you forward through millions of years defined by the rise of the vertebrates. The simple, jawless fish of the Cambrian slowly evolved jaws, granting them the power to bite, to crush, and to dominate the marine environment. The oceans became a world ruled by motion and muscle. We move now into the Silurian period, about 440 million years ago. While the oceans were vibrant with life, the continents above were barren, silent, and exposed to the harsh elements. A vast, endless landscape of naked rock, sand, and dust. No shade, no shelter, no soil, but life is persistent. It pushes. Imagine the absolute silence of that desolate land. Now, slowly, gently, visualize the first microscopic organisms, bacteria, and algae forming thin, crusty biofilms on the damp edges of the land near the shorelines. This was the first quiet attempt to colonize the land, a monumental step that laid the foundation for everything green we see today. Around 420 million years ago, the true revolution began with the plants. Picture the first primitive plants, tiny, low-growing, non-vascular mosses and liverworts clinging desperately to the rocky shorelines. They faced incredible challenges: the sun's UV radiation, the constant threat of desiccation, drying out, and the need to transport water and nutrients without the support of the ocean. Evolution answered these challenges with elegant solutions. Plants developed cuticles, a waxy layer to retain moisture. They developed roots to anchor and draw water from the emerging soil. And critically, they developed the vascular system, xylem and phloem, an internal plumbing system to move water up and sugars down, allowing them to grow taller, reaching for the sun. As plants grew taller, they covered the land in a spreading green carpet. This had a profound effect on the entire planet. They broke down rock into fertile soil, stabilized the climate, and, through continued photosynthesis, permanently boosted the oxygen levels in the atmosphere, creating the crisp, breathable air that exists today. Let the image of the green world slowly expanding across the continents soothe you. Feel the quiet power of the sun nourishing the chlorophyll in the leaves. This is the quiet conquest of the land. Now, the stage is set for the animals, the newly formed forests and swamps of the Devonian period, the age of fish. Around 400 million years ago, offered new food sources and shelter. While the fish ruled the water, some of them were experimenting with survival in shallow, oxygen-poor swamps. Imagine a specific type of lobe-finned fish resting in the stagnant, warm shallows. The oxygen dissolved in the water is low, forcing the fish to gulp air at the surface. Over millions of years, the simple swim bladder used for buoyancy slowly evolves into a primitive lung. Now, visualize the slow, profound change in the fish's fins. In these shallow, murky waters, fins that are strong enough to prop the body up and paddle slowly across the muddy bottom offer a distinct survival advantage. The bony elements within those fins become stronger, thicker, and more articulated, resembling the bones in our own arms and legs. This brings us to a crucial transitional creature, like the Tiktaalik around 375 million years ago. Picture this creature. It is a fish covered in scales with fins, but its head is flattened like a crocodile. Its eyes are on top of its skull, and it possesses a strong neck, allowing it to lift its head and look around. Most crucially, its pectoral fins have the robust bone structure of a lemur shoulder, an elbow, and a wrist. Feel the sensation of taking that first tentative step. The moment the weight of the body shifts from being supported by water to being supported by bone against gravity. It is a slow, difficult, but revolutionary act. These pioneers, the first tetrapods, four-limbed vertebrates, did not immediately abandon the water. They were the amphibians, tethered to the moist, warm swamps, needing water to keep their skin wet and to lay their gelatinous eggs. They were the true bridge between the two worlds. Rest now with the gentle sound of the Devonian swamp surrounding you. Hear the low, rhythmic croaking of the early amphibians, the pitter-patter of tiny, newly emerged legs on damp soil. It is a slow, methodical rhythm of movement, a quiet celebration of survival on the ancient earth. That the great exodus from the ocean was complete. Life had conquered the land, but it still required moisture. The next step to conquer the dry, vast interiors of the continents required one final, brilliant innovation. Let the image of the slow, determined walk of the first amphibians guide your thoughts to stillness. The sound of water meeting the shore is now the rhythm of your breathing. Sink deeper into the quiet certainty of evolution's slow, unstoppable progress. You are safe here, resting at the edge of the ancient sea. Let the gentle rhythm of the ancient swamp fade away as we move forward into a time of enormous scale and dramatic change. We leave the moist, tethered world of the amphibians and transition into a new geological era, one defined by life's ultimate conquest of the dry, continental interiors. This begins with the invention of the amniotic egg. Imagine an animal laying an egg not in the water, but on the dry land. This ingenious package an embryo surrounded by membranes that protect it, feed it, and manage its waste was the key to true independence from the water. This single innovation allowed the earliest reptiles to spread across the entire globe. leading to the rise of massive dominant forms. As you relax, let us enter the time of giants, the Mesozoic era, often called the Age of Reptiles, or more famously, the time of the dinosaurs. We move first through the Triassic period. The continents were fused together into one enormous supercontinent called Pangaea. This vast landmass created extreme climates, scorching deserts in the interior and warm, moist coastlines. It was a world of slow, arid change. Out of this landscape, the ancestors of the dinosaurs emerged, alongside the first tiny, struggling mammals. Feel the dry, warm air of the Triassic on your skin, a vast, silent, and hot environment. Then, we transition smoothly into the Jurassic period. Pangaea began to slowly rift and break apart, leading to a more humid, stable, and warmer climate worldwide. The planet became a lush, green canvas, covered in vast forests of cycads, conifers, and ferns. It was the perfect stage for the spectacular diversification of the dinosaurs. Visualize these magnificent creatures. Do not picture them as monsters of sudden chaos, but as slow, deliberate sovereigns of the ancient forests. See the immense, plant-eating sauropods, like the Brachiosaurus, moving with the slow, powerful grace of geological forces. Their long necks reach high into the canopy, their enormous bulk supported by pillar-like legs. Their footsteps are not rushed. They are deep, heavy thuds against the earth, a slow, comforting rhythm that has defined life for tens of millions of years. Feel the profound sense of scale. Everything is large, quiet, and deliberate. Observe the flight of the pterosaurs, the giant flying reptiles, with wingspans sometimes exceeding the size of small planes. They glide effortlessly on the warm currents, masters of the air, their movements mirroring the slow, sweeping passage of clouds across the sky. Even the predators, like the formidable Allosaurus and later the Tyrannosaurus rex, move with a majestic, unhurried pace. They are not chasing hastily. They are observing, conserving energy, an embodiment of massive, controlled power. Their roars, if you can imagine them, are not sharp shouts, but low, deep reverberations that travel through the thick jungle air. This peaceful reign of the dinosaurs lasted for nearly 165 million years. Imagine the deep stability required for life to sustain such colossal sizes for so long. It is a profound meditation on the power of consistency in time. But even the most stable existence is subject to cosmic forces. We move now to the end of the Cretaceous period, 66 million years ago. The world was still lush, and the dinosaurs were at their peak diversity. But then, a sudden, catastrophic change. Picture the sky. Not blue, but momentarily filled with a blinding flash, followed by a vast, suffocating darkness. An enormous asteroid, estimated to be 6 miles wide, struck the Earth in what is now the Yucatan Peninsula. This impact released the energy equivalent of millions of nuclear bombs, triggering massive tsunamis, volcanic activity, and most crucially, covering the entire planet in a thick, dark dust cloud that blocked out the sun for months, or perhaps years. The global darkness was the true killer. With no sunlight, plants, the base of the entire food chain, died. The large, dominant dinosaurs, unable to sustain their massive metabolisms in the sudden cold and darkness, perished. This was the great, quiet reset button of life. Feel the chilling silence of that sudden darkness. The world stops. Yet, this tragedy for the giants was the ultimate opportunity for the small and the adaptable. As the dust settled and the sun slowly returned, the world was inherited by the survivors. These were the organisms small enough to find shelter, fast enough to reproduce, and resilient enough to eat anything seeds, insects, or decaying matter. Foremost among these survivors were the mammals. The mammals had been living in the shadows of the dinosaurs for over 150 million years, tiny, shrew-like nocturnal creatures, keeping a low profile. They were defined by brilliant innovations, warm-bloodedness, endothermy, allowing them to thrive in the cold darkness, and the ability to bear live young and feed them with milk, providing a protective start. Imagine the transition. The forests are empty of giants. Now in the twilight, tiny, furry forms cautiously emerge from their burrows. The Paleogene period begins the age of mammals. In the absence of their massive reptilian overlords, mammals exploded into every vacant ecological niche. They became the fast runners, the deep swimmers, the graceful gliders, and the clever tree dwellers. Picture the slow, steady diversification, the emergence of the first horses, no larger than a dog, the early ancestors of the whales making their way back to the sea, and crucial to our own story, the evolution of the primates. These early primates were small, agile creatures adapted to life in the dense tropical canopies. Their survival relied on grasping hands and feet, giving them superior ability to climb, and forward-facing eyes, giving them the depth perception necessary to leap accurately from branch to branch. Above all, their survival relied on intelligence, larger brains for memory, spatial awareness, and complex social interaction. Let the image of the dense, warm canopy surround you. Hear the gentle rustling of leaves, the subtle chirping of the small, resourceful mammals. This is a world of agility, cleverness, and quiet resurgence. The age of immense, unthinking power has passed. The age of adaptability, warmth, and intelligence has begun. The stage is perfectly set for the final, most profound leap in our evolutionary journey. Rest now, carried by the quiet, persistent pulse of mammalian life. Feel the warmth of your own body, a direct inheritance from the tiny, tenacious creatures who survived the darkness and began the long ascent toward consciousness. Sleep deeply as the last chapter, the story of humankind, gently approaches. Let the gentle echoes of the age of mammals settle around you. The sound of the rustling canopy and the cautious steps of the first primates now guide us toward the most recent, most profound, and most rapid chapter of the evolutionary story, the emergence of the human lineage. We're now focused on the Cenozoic era, within the dense, warm forests where the earliest primates made their home. Visualize these small, agile creatures, perfectly adapted to the three-dimensional world of the trees. Their existence depended on a few brilliant innovations that you carry within you today: grasping hands and feet for secure climbing, and forward-facing eyes that provide the binocular vision necessary for accurate depth perception when leaping from branch to branch. Feel the subtle, evolutionary shift in your own hands as you lie still. The ability to grasp, to manipulate, to explore, all began in the ancient canopy, a necessity for survival among the swaying leaves. The key to the primates' ascent was not brute strength, but intelligence and social complexity. Life in the canopy demanded larger brains to map complex territories, remember fruit locations, and manage intricate social hierarchies. This was the silent cerebral foundation of our journey. Now, fast forward dramatically, approximately 6 million years ago. The climate changes. Geological forces create the Great Rift Valley in East Africa, leading to a profound transformation. The dense, continuous forests give way to vast, open grasslands, the savanna. This environmental shift presented a massive challenge. To survive in the open, exposed savanna, our primate ancestors could no longer rely solely on climbing. They needed to see over the tall grasses, spot predators, and cover long distances efficiently. Imagine the struggle, the necessity that drove the most defining change in our lineage. Bipedalism. Picture an early hominin like Australopithecus standing upright. It is a slow, gradual, initially awkward movement. The pelvis is reshaping, the spine is curving, the feet are losing their grasping ability to become levers for propulsion. This transition was the most consequential walk ever taken. Standing upright offered immense advantages that allowed our ancestors to thrive, freeing the hands to carry food and tools, improving long-distance endurance for hunting and gathering, and reducing sun exposure by presenting a smaller surface area to the midday sun. Feel the stability of your own upright spine, a direct inheritance from those first brave steps on the ancient savanna. There is no rush, only the steady, persistent rhythm of walking across millions of years. The development of bipedalism profoundly changed the dynamic. With hands now free, the use of tools began. We move into the time of the hominids, creatures like Homo habilis, the handyman, around 2.5 million years ago, who began chipping stones to create sharp edges. These simple tools were not just instruments. They were extensions of the mind, representing the capacity for foresight, planning, and abstract thought. Observe the quiet ingenuity of that moment. A brain visualizing a sharp edge hidden within a round rock, and the hands working patiently to reveal it. As we progress through the evolutionary timeline, a second, equally important change occurred: the expansion of the brain, with the consumption of nutrient-rich meat made possible by tools, and the reduced energy cost of walking upright. Resources were diverted to the most powerful organ. The brain case began to swell. We meet Homo erectus, the upright man, around 1.8 million years ago. A creature that mastered fire, a discovery that provided warmth, safety from predators, and crucially, the ability to cook food, further increasing nutrient absorption and fueling even larger brain growth. Imagine the flickering light of the first controlled fire. It represents warmth, community, and the first true step into culture. The firelight becomes the center of the world, illuminating faces, sharing stories, and forging social bonds. We move now to the emergence of our own species. Homo sapiens, around 300,000 years ago. The physical changes were subtle, but the intellectual and cultural changes were revolutionary. The defining feature of Homo sapiens is not bipedalism or tool use. Those were shared with earlier hominids, but the capacity for abstract thought. symbolic language, and complex spirituality. Imagine the early human mind, capable not just of seeing a tree, but of using a word for tree, capable not just of seeing a hunt, but of telling a story about the hunt, capable not just of seeing death, but of contemplating a meaning beyond it. Feel the profound power of language, the intricate web of sound that allows the sharing of knowledge across time and space. This is the ultimate evolutionary advantage, the ability to learn from the accumulated experience of others, to build a collective knowledge. This cognitive revolution led to art, music, and ritual. Picture the hands of our ancestors painting bison and horses on the walls of dark caves around 40,000 years ago. These were not just drawings. They were acts of spiritual connection, narrative, and beauty. They represent the moment when the practical, survival-focused mind gave birth to the poetic, searching soul. As you lie still, contemplate the vast journey of consciousness, from the simple chemical reactions within a protocell to the complex neural network that allows you to listen to this story and process its meaning. Your very ability to relax and contemplate is the culmination of billions of years of trial, error, and triumph. The evolution of humanity is not a finished story. It continues now, not primarily in our genes, but in our culture, technology, and collected knowledge. The changes happen at an accelerating, yet still peaceful, pace. You are the momentary crest of this enormous, relentless wave of time. You hold the entire history of the cosmos within the structure of your cells, your bones, and your thoughts. Let the knowledge of this vast, powerful lineage give you an ultimate sense of peace and security. You are the product of immense resilience. The long journey from the dark ocean to the starlit cave has led us to this moment of rest. Rest deeply now, carried by the intelligence and spirit of those who came before you. The story continues, but for now, your role is to find stillness, peace, and restorative sleep. You are safe in the arms of time. Our long journey through time has finally reached its gentle conclusion. We have traveled from a searing hot planet, ruled by volcanic fire, to the complex, thought-filled world in which we reside. From the very first, lonely cell that sparked in the darkness to the magnificent yet tragic reign of the dinosaurs. From the first awkward steps of amphibians onto dry land to the final, most crucial step, the self-awareness of the human being. Every tiny change, every severe test, every extinct species was a necessary stage to create this very unique moment. You are not just a listener. You are the direct, living result of this endless, relentless process. In your bones lives the legacy of the first fish, and in your consciousness lives the fire lit by the earliest hominids. The story of evolution continues, but for you now, it is a time for absolute stillness. Let this incredible journey, billions of years in the making, fill you with a profound sense of security and belonging. You are part of this rhythm. Allow any lingering thoughts to simply drift away. Your mind, like the ancient ocean, is perfectly calm. Let go of everything. I wish you a deep, peaceful sleep. Sleep well.